to introduce Ted. Ted M. Young. He's a technical coach, speaker, and author. He's like us, where he's a big fan of TDD, ensembling, refactoring, and also, if you look over his shoulder there, there's Jitter Ted's TDD game, which I've never tried, but I'm excited to learn more about at some point. And that's all the talking I'm going to do for a while. Thanks very much.
Yeah, actually, there's some folks here who either own and or have played the TDD game. So if you go to tdd.cards, you can find out more about it. I won't advertise it much more than that, but it actually is a fun game for TDD. But we're here to talk about something related, which is testable architecture. And so a couple of notes, right? This is a TED Talk, and if you want the slides and recording and stuff like that I mentioned, you go to ted.dev/talks, and you'll see past talks. You'll see any scheduled talks I have coming up, things like that. If you want to know more about me, where you can find me on social media, or my Twitch live coding that I do a lot of, or my YouTube channel, the links are all on your screen, but just go to ted.dev, not hard to remember. And you can find out more about me and what I'm doing and where I am. Let me push the right button. There we go. So as I mentioned, ask questions as you need it, but I do reserve the right to say, I'm going to talk about that. And then I will eventually answer your question. And if I end up not answering your question, then re-ask it. I don't want you to go away without questions answered. I want you to be as unconfused as possible. So tests, why do we bother? What are they for? Right? What I'm a big fan of tests, but they're kind of two things that they're for. And this very much relates to test-driven development, which is much more about defining the desired behavior. Right, so specifying what you want. So those are some kinds of tests, and when you're writing tests first, you're writing what you want first, and then at some point, hopefully very soon, you will get to implementing what the test is specifying. If you're not doing TDD, you're not doing tests first, then you're hopefully writing some tests, and then those tests are basically verifying the behavior that exists is what you want. Sometimes this is referred to as validation. I will not get into the pedantic discussion of verification versus validation. All that matters is when you write tests after, you're basically saying, this is what I want. And by you, it could also be some AI LLM that's doing that, where it's like, here's some code, write some tests for it. The downside of that is if the code is wrong, it's going to write tests to confirm that the code is wrong. But hey, it's at least testing what it is, and sometimes that's useful. We call those characterization tests. Whatever it does right now, I want to make sure it stays doing whatever it's doing right now so that maybe I can do some refactoring. And if you're doing refactoring without tests, I hope you have a lot of time on your hands to figure out what goes wrong when that happens. There are some techniques, but we're not going to go into too much of that of how to refactor when you don't have tests, but usually it's write some tests. So some attributes of tests that we might think about, isolated is really important. We want tests to be able to be isolated from 2 points of view. So often tests, we think about test isolation as, I want to run this test by itself and it should just work. I don't want them interacting with other tests, so they should be sort of isolation, sort of independent. But one of the things that's most important for me is the readability. I want to be able to look at a test and all the knowledge that I need about that test is there. Why is it asserting x equals 3? I want to know why. Why 3? Why not 2? It should be somewhere in that test without me having to look all over the code base. They should be automatic. I shouldn't have to, in the old days, I think we hopefully take for granted that we have developer tests, unit test frameworks, and sometimes even they'll run automatically all the time. There are tools that do that. IntelliJ Ideas recently added that functionality, and there are other plugin tools that allow that. But we want it automated, right? We want to not be prone to mistakes by doing manual testing. It's not a lot of fun to have to do manual tests over and over and over and over, and then wonder, did I do something wrong or is there a bug? So we want them automated. Concise, and sometimes that's hard. I've myself written tests that perhaps are a bit longer than they should be, but we'd like them to be targeted at specific observable behaviors. And self-verifying, we shouldn't have to look at anything, right? It should basically tell us, yes, it passed, or no, something's wrong. And just because something's wrong, if you're doing TDD, that's not necessarily a bad thing, as long as you said, I think it's going to be wrong in this specific way. That's actually a good thing. Eventually, you'll want it to be correct, but being wrong in a predicted way is really important to me. Precise, like if it's going to be 10, then it better be 10, and you better know exactly why it is that value. And so we want that precision, not just in the test itself, but also in the reporting of errors, reporting of failures. I want it to be precise about and tell me exactly what's wrong. I don't want it to be, well, somewhere something failed. I don't want to know where. It just failed. The concert ticket didn't get purchased. Where? What went wrong? And so that's where we start thinking about at what level or layer or aspect of our code are we testing. And they better be predictable. I used to deal a lot with flaky tests. That is generally not a problem for me anymore. And so we want our tests to be predictable. If they pass, they should remain passing. If they fail, then we should fix them. But they should fail again if we don't fix them. If they fail sometimes and pass sometimes, you've got a predictability problem, and that test is not going to be very useful. And we'll look specifically at some ways that we can get out of that predictable or unpredictable problem area. And we write them. That we as developers are writing them, hopefully in coordination with the folks who are defining the behavior that they want. We don't want, handoffs of tests and things like that. I used to do that. That doesn't work very well. You want the people who are writing the code to be writing the tests in a way that's understandable to them, as well as hopefully those who are defining the behavior. And ultimately, I want tests to run fast. And the reason why is because the sooner you find out you broke something, the easier it is to fix. If I just wrote some code and now the tests don't pass, and they were passing before, I know it must have been some point between the time I ran the tests and now, right? Before that, and if that time period is 2 minutes, then it's going to be, I did something in the last 2 minutes. At worst, I undo it, revert back, and try it again. If it's 2 hours, a little bit more difficult. 2 days, well, okay, now you may as well just, run it in the debugger and figure out what's going on. And so we want as many of our tests, because not all of them are going to be able to run within seconds. I want tests to run on the order of seconds, preferably the ones that I run frequently. I want them to run in less than 2 seconds. Mostly because I'm doing TDD, so I want those very, very tiny steps to go very quickly. But it's way better to have the tests run faster, especially if you use tools like mutation testing tools. Because one of the things that a mutation testing tool does is it purposely changes your production code to see if any tests fail. If it changes your production code and no tests fail, you're missing tests, and that's not good. The problem is it's got to change a little piece of code, run all your tests. Change a little piece of code, run all your tests. Change a little, right? And you can see it's going to be running tests a lot. And there are ways to optimize that. It won't rerun tests if it doesn't think the code has affected it. But in general, it's really good to have fast tests. But even just writing tests is hard. And so let me know in chat, what are some things that make it difficult to write tests? Why is it so hard? I find it easy, but I've been doing it for 25 years. Yeah, inexperience, that is absolutely true. Colleagues. Well, why were the colleagues finding it difficult? That's the question. Hardware is interesting. So embedded systems, those can be really difficult. And there's there's some of the things we'll look at can help with that. Yeah, pressure to move faster. And it's ironic because if you get better at writing tests and you write more tests, you can actually go faster. Randomness, absolutely. We unfortunately have to deal with the external world. We don't run in a little bubble where we control everything. Frameworks, whether they're heavy or light, opinionated or not, although a framework to me is by definition someone's opinion. So all these things, these are all great. And it's, yeah, if code's not written with tests in mind, right? That's why writing tests after can be hard, because, oh, I need to observe this little piece of information. I can't see it. I can tell it at a distance through this other proxy, but now it's imprecise, and now sometimes it fails, and I don't know why, and it's not really the cause of. It looks like there's some other thing going on. So, in my experience, classes are poorly organized. We don't quite know where to put things, and one of the big things, and this is going to be the majority of what I'm going to be talking the rest of the time about, is mixing logic and I/O. This is a killer. This is the death of testing. And this is where you start getting heavy mocking tool usage, which, if any of you know me, you know that I am mostly against, unless you have to, but generally advise against. And so when I talk about poorly organized classes, is you've got too much state, classes that have too many responsibilities, and you're trying to test some little piece, and there's all this other stuff that you have to deal with that is irrelevant for your test. And things that we mentioned, infrastructure, right? Hardware, frameworks, these things get in the way. And so we're mostly going to focus on this side of the equation, as it were. And when I talk about I/O, I am really referring to anything outside of the current process. I kind of think about it as, I want most of my tests to be testing against code that runs in memory. That's it. If it accesses anything else, that's I/O. And so that includes hardware. Makes some kind of sense, although you may not think of accessing the system clock as I/O or random number generators, although certainly you start to think about local files as being I/O. But all these are I/O. All of these are outside your process. All of these are basically not under control of what code you're writing. Obviously, remote services, whether you're accessing them through HTTP requests or message queues or RPC or whatever, or if you're still using Corba, God forbid, all these things are remote services and you don't have control over them. Heck, they may not even be available. Databases is obvious, even in-memory databases. So I don't use in-memory databases very much anymore because I'm in the Java Spring world, and we have test containers, which are awesome and mean that I don't need to use an in-memory database for speed, because I can have Postgres up and running all the time for testing purposes only, and the tests run as fast as they're going to run. I don't have to wait for the database to start up. But they're still out of process. And any other processes that you happen to be accessing if you have special hardware. And I include frameworks, even though it's like framework I/O, that's not really I/O, but it's something that is overhead that you don't have direct control over, right? To me, the difference between a framework and a library is, a library, you're in control, your code is in control, right? Your code gets to decide whether it talks to this library or that library, do this thing or that thing. A framework is, we're going to call different parts of your code, and you may not know which we're going to call when, right? So who's in charge? Libraries, I'm in charge. Frameworks, they're in charge. I like to be in charge when I'm writing my tests. So I have this acronym, this is a terrible acronym, but what it stands for is basically separating the concerns of I/O and non-I/O for testability. It's a mouthful, and that's why I just refer to it as testable architecture. Right, so we want to separate our concerns, and the concerns that we're separating are I/O and non-I/O. And so again, it's we want speed, ease, and predictability, right? We want fast tests. And anytime we do IO, our tests are likely going to be slower. We want them to be easy. Anytime we've got IO, there's going to be extra stuff that we have to deal with. Predictability, right? I mean, guaranteed doing file access and of course random numbers are not going to be predictable. And so all these things we want to avoid. And because for me this is so important, I really now avoid the use of the term unit or integration. I think those are terrible terms because every single time I get into any kind of discussion that might turn into a debate about, is this a unit test or not? What's a unit? Honestly, I could care less. I don't care. Is this an integration test? Well, it's hitting this thing, except it's not the real thing I've substituted. Is that an integration test? I don't care. Doesn't matter to me. And so for me, there are two kinds of tests: IO-based tests and IO-free tests. The IO-free tests should be practically free to execute. They run in memory, so all you're paying for is, if you're running in Java, the Java JVM startup time and the time it takes to instantiate your objects, which really should be no time at all. And so if they're truly IO-free, you should be able to run 1 or 1,000 in almost about the same amount of time. That the overhead is mostly in starting the thing up. Tony asks about the testing container. I'll talk about that. Remind me at the end. I'll talk about that. It's really easy to set up, and once you have it set up, it's awesome. But those run fast, but they are not basically instant, which is what I want from my IO-free tests. So let's look at an example. So here we have a little application that, you know, if you were in school or in a boot camp, you might have written way back when. It prints a little menu, and then it uses the infamous scanner to gather your choice. What did you want? Did you want a burger, a pizza, or fried chicken? You chose it. It then assigns a price, calculates tax, and then totals everything up, and then prints a receipt, and it uses a specific currency format to get that, and then prints it out to the console. How do you test this? Well, one way is you manually test it. But how would you write an automated test for this? Anybody know? If you haven't done this, there are tools to basically simulate somebody typing at the keyboard. Yeah, like a pipe of some sort. And in the JUnit world, there are some tools to do this. I've written some, because sometimes this is the code you're given, and you've got to write tests for it before you can start refactoring it. And Lada's already ahead of the game. She's just going to go refactor and introduce a seam. But I might want to test this, and so I can do it, but it's hard, right? I want to make sure that, you know, I mean, it's likely that I don't need to test that the first choice is 1195. I'm probably going to be calculating, like, is the tax calculated correctly? And there are other ways to refactor this but the idea is, this is very much the kind of code I see a lot of. There's a mixture of fetching information from places, whether it's the console, usually it's another service, or maybe it's the database, but it's like we're fetching information, we do something on it, and then maybe we send it out somewhere or save it. That is like most applications, what they do. Fetch information, do some calculation, make some decision, and then send it out or save it or notify it, right? So there's this input, processing, and output. That's most applications, or at least most sort of tasks in an application. Yeah, you end up basically sort of replacing the println and the input with something. But that's annoying, and that's hard. And what happens if the menu order changes? It wasn't alphabetized, and they wanted it alphabetized. Okay, we got to swap the fried chicken and the pizza. Well, now it's the 2 and the 3 are swapped. Well, now you got to go change your tests. That's kind of annoying. Right? And so this is the code that would test that. This is the test that would test that code. So we basically simulate it. We do all sorts of fancy stuff with byte array input streams. and we just set the input field, and then we send the choice, and we call the method, and we call the main, and then we check the output string, and then assert that the output string looks like what we want. This will work. It is not fun to write these. And right, we're doing a lot of stuff that really has nothing to do with, did it calculate the frickin' tax correctly? That's all I care about. Why am I doing all this other work? So, as Lana mentioned, let's refactor out the stuff that we care about. Right? This is the domain logic. This is what we want to be really careful about testing. Now, it's not that we don't care about the I/O part, but I don't want to write tests every single time, all of them that have to go through the I/O. I may have 1 or 2 tests to test the I/O, right? Test to make sure that, hey, if you selected one, it selected the burger. But other than that, I don't want to test the calculations indirectly. I always liken it to trying to turn on a light switch with a broomstick. You can do it. But do you want to always have to do that? No, of course not. I mean, some people are like that, but I'm not. So what we do is we separate the concerns. Right? We say, let's split out the part that calculates the receipt from the part that decides and collects the information from the user and then sends it back out, sends the result back out to the user. Right? We've pulled out the decision making and calculation. That is our domain logic. All of our behavior of our systems is calculations and decision making. Right? Decisions based on calculations, decisions based on information, decisions based on information and calculations, plus some input. Right? It's all, that's what logic is. It's decision making. And we want to test that. But we want to test it directly. And so once we've separated this, then it's much easier, right? It's one line of code to call the thing and then checking the text. And you could certainly imagine that there might be better ways even than testing something that's as fragile as text output. But this is a great first step. And then to use it, right, what's magical is I can now take that code that did that calculation and they said, we don't want a console app anymore. We want an endpoint for a GET request. Easy. I just call the same thing that I was calling before, which is right here, compute the receipt. I got the input from a different place. Instead of the console, I'm getting it in from an HTTP request. I'm sending the response in a different format and through a different mechanism. Right? Instead of printing it out on the console, I'm sending it back through the HTTP response. Right? So we now have 2 benefits. We have way easier to test and much more reusable. And if we always apply this to all of our code, then we have code that naturally falls into 2 parts. The part that's managing the outside world and interactions, and the part that's doing what the folks who are paying us to do stuff is make these decisions based on what the behavior they defined is. Good question. Would I test a receipt controller? Absolutely. However, I would test that it calculated things correctly. I would test, did it parse the choice correctly? Did it give me a response? But I'm not going to further examine the content of the response to see, did it calculate the tax correctly? I already have a test for that. It's right here or here, right? I don't have, and that's the other thing is what you end up doing is you end up not having to again, test this logic calculation at a distance, which is hard. It's harder. There's a lot more setup. There's a lot more things that you have to do. There's conversion of things to text or objects you have to do. I just want to test the calculations directly. So that's a really good question, is that we still need to test, well, did we get the string correctly? If one got sent or some other mechanism. But the point is then I'm testing only the code that you actually see here. The thing that we call this compute receipt for, we don't need to test anymore. And that makes life so much easier. All right, so I said, in addition to testable, right, we've got architecture. So architecture is a funny term. And, some folks say that architecture is a way of organizing thoughts or provides the structure of a system, defines interactions between components, the vision of the application, boundaries of different parts, scopes and responsibilities of technical deployment. One of the most famous sort of answers to this question is the decisions that are expensive to change. Grady Booch uses this a lot. Ron Jeffries talks about the big rocks versus the small pebbles, right? These are the big rocks. You don't get those, if you don't get those boulders right, then it's going to be hard to fit everything else together. And so from what I'm going to be talking about in terms of architecture really is about organization of code. Right. So there is also the very important deployment and operational aspects. And things like how am I splitting up the application into its different pieces? And this is basically the difference between layers and tiers. And I often see this confused. Layers are not tiers, tiers are not layers, yet the lines have blurred and people start using these interchangeably. Layers are inside of your application. Tiers are how the different aspects talk to each other and are distributed in the deployment. So I'm mostly concerned about the layers. And layers get a bad name, and I think it's unwarranted. I think, like anything you do, you can do anything bad, right? You can do really good developers can take any architecture and get a good, reliable application out of it. And developers who are not so experienced or maybe don't quite understand things, they can take what would otherwise be a great architecture and really mess things up. Might be a lack of understanding of coupling and cohesion. So I run a book reading group, and we finished a book called Balancing Coupling and Software Design by Vlad Kononov. Highly recommended. And it really, the idea of coupling is bad and cohesion is good is far too simple and is actually much more subtle than that, because not all coupling is bad. You have to have some coupling. The question is what kind and how much and where. And high cohesion is often nice, right? That things make sense together, but you don't want to put everything in one class because that's great. Everything's in one class. That's not great either. So these kinds of things affect how we understand and design our systems. So our testable architectures, there's like lots of the architectures that you probably have heard of are testable in this way, right? So we've got clean architecture, hexagonal ports and adapters. There's an original diagram from Alistair Coburn. You've got the onion architecture. You've got imperative shell functional core, boundary control entity. This one is old, predates, I think, just about all of these, and A-frame architecture from James Shore. These are all doing the same thing in terms of separation of concerns. They're trying to separate infrastructure, those kinds of concerns from our logic. They just do it in different ways. So clean architecture has dependency direction. So dependency direction is really important to keep things separated, right? So you'll notice in the center are our entities, right? That's our domain, right? Our use cases. We don't want them depending on anything else. Why? Because I want to be able to instantiate, right? New up one of these entities and execute a command against it. I don't want to have a database up and running. I don't want to have my system up and running. I worked at a company called Guidewire Software, and our architecture was such that you had to have the server up and running before you could do anything. You could not actually write an IO-free test. You can imagine how fun that was for me. And so dependency direction ensures that we keep things that way, right? We have the outside world depending on our domain, not the other way around. And that's a different way of thinking. It's like, well, how does the use case fetch the concert event so it can find out if tickets are available for purchase? Well, it's not up to the concert entity to retrieve itself. We used to think that way. But that's really bad because now you've now got a coupling between your object and a database or something else, and now it's much more difficult to write the test. Instead, let something else outside of that go and fetch it, and then that entity, that object, is completely ignorant. It has no idea how it got to be, right? It's like it appeared in memory and it's magic. It doesn't know how it got there. It actually doesn't matter for its behavior. So clean has some nice layer separation. One of the things it doesn't have, and we'll see that other architecture sort of diagramming or ways of thinking about it. Here, it kind of stuff is spread all over the place as just circles, but like left side, right side don't have any meaning. And there's no sort of separation of this idea of adapters or drivers or service provider integration kinds of things. But it's got that separation, that idea of direction dependency and separation between domain logic and infrastructure. Onion architecture is quite similar. It has the dependency direction layer separation. Any outer layer can call any other inner layer. It doesn't have the left to right asymmetry, and it doesn't really have the separation of infrastructure. BCE, boundary controller, control entity, same thing, right? You've got your boundary objects. Those are the things that deal with the outside world. You've got your controllers that organize and orchestrate things, and then it's the entities that implement most of the domain behavior. And what's really interesting about BCE is there was a diagramming method for ensuring that you did things correctly, that you didn't hook up an object to another object that didn't belong. And this is called a robustness diagram. And so you've got a whole bunch of things that are allowed. So an actor can talk to a boundary, of course. A boundary can talk to a controller, makes sense. A controller can talk to another controller if it needs to, and a controller can talk to an entity. An actor cannot directly talk to a controller. It can only talk to a boundary object because the actor is doing all sorts of weird stuff that has to be interpreted by the boundary object. And the boundary object should not talk to another boundary object. That's just weird. Now here it says entities can't talk to entities. That's its own variation. In my world of domain-driven design with tactical patterns, this is actually okay. But if you're doing this, the rules make sense if you start to think about where is the business logic, domain logic, and where is this interaction with the outside world. I'm not sure I would call model view controller an architecture, but it kind of is. And it's the same thing. We've got this thing out here, right? The actor, and they manipulate stuff. They click a button, they type a key, and it goes to the controller to be interpreted. So here, the controller is actually the boundary. And this is where things get confusing. It's like, here they use the term controller. Well, wait, what about boundary control entity? Different worlds. And if you know domain-driven design, different bounded contexts. So words mean different things, and that's okay. And then it does stuff with the model. And then a view is the interpretation the other way. So a command or request comes in, change of state, does a notification to update the view. In fact, you may have it notify multiple different views, right? Simultaneous views. If you've got a spreadsheet, it might change the cell value and a graph that is of those cell values, and they change at the same time. And then there's Hexagonal, which is my preferred base for my testable architecture. Hexagonal by itself is insufficient, and I'll talk about that in a second, but Hexagonal has the same dependency direction, so everything must point only inwards, right? So I can't have my domain call out to a user interface. That makes no sense. It cannot, the domain itself cannot call out to an external message queue. Some notifier doesn't come in this way, and so there's actually some asymmetry between the sides. So we've got layers, and so the difference between what I do with testable architecture with builds on Hexagonal is I add on domain-driven design, and that's where this central core of domain exists. And so I basically take what's inside the hexagon and split it into two parts. Alistair Cockburn, when he wrote up the pattern, also called ports and adapters, said, you do whatever you want in here. I'm agnostic. I don't care. Personally, I do care. I want you to separate them because I think it's really valuable to do so. And we'll see that when we get to actually looking at tests against this kind of architecture. So any outer layer can call any other inner layer, although generally user interfaces and inbound things that are on the left side talk to the application layer. And so then it can coordinate with retrieving information from the outside world and then basically pulling the domain into memory. And it's got this asymmetry, which I think is really nice. You can read it sort of from left to right as terms of how an application works, right? Somebody clicks something on the user interface, stuff happens, the application layer goes and requests stuff from persistence, and then the domain does its decision-making, and then we return something back out to the user interface. And we have a nice clear separation of our infrastructure with these dedicated adapters. These are the boxes on the outside. And so hexagonal plus domain-driven design plus the split of application into our core domain that is completely ignorant of the outside world and how it came to be, plus the layer that helps coordinate with the external world, because you have to do that. At a minimum, you're going to be loading these domain objects from a database, right? If I've got a concert ticketing system and somebody wants to buy a ticket, I need to make sure there are tickets available. I also need to make sure the concert is in the future, not in the past, right? So there's all sorts of rules that concert entity is going to implement. But how that concert object got to be instantiated and loaded into memory is an external concern, right? It's not the domain object's concern. It's just concerned about, you just asked me to buy tickets. Do I have enough? Let me see. Yes, I've got some state that tells me I have enough. Here you go. Everything's good. And so the things that load those domain objects into memory, perhaps it requires coordination with external services, payment systems to make sure the payment went okay. That's the application layer. And so hexagonal plus domain-driven design to me is testable architecture. Now, hexagonal architecture is not a specification, it's a pattern, right? It's a way of splitting these things up. And so you can look at the way people talk about hexagonal, and sometimes it'll be different. I think sometimes people misinterpret what Alistair Cockburn originally said. Sometimes the word interface is misunderstood because it has a general meaning and then has a meaning inside of the Java language and similar languages. And those two often get confused, right? Because I can talk about an object that has an interface, does not mean that it necessarily implements a defined interface type. It has methods on it that I can call. That's its interface. But it can be confusing to talk about that way. But that's you look back at the patterns books in the 90s, that's what they meant by that. So this is a quote from Alistair Cockburn's original write-up, and I think it's the core reason why I came to be using hexagonal. And so I'm going to emphasize a couple of things. Allow an application, right? The stuff that's implementing your domain logic, right? The purpose, why does this system exist? In order to implement some behavior. And that it can be equally driven by users, programs, basically other systems through maybe an API, and automated tests. They are on a level playing field, which is a very different way of thinking about systems. It's like, I have this core behavior, I don't care who's calling it. I don't care if it's a user through some, HTTP request, or whether it's another system through, gRPC. I should not have to care. Unfortunately, a lot of our systems do, and that's where they get into trouble. And tested in isolation, right? So there are two parts to this. One is the application core doesn't care who's calling it. It's on a level playing field. And that it can be tested in isolation independent of the runtime devices, databases, external services, because otherwise we can't test effectively. Now, it doesn't mean we don't test it with those runtime devices and databases and external services eventually, but that should not be our primary testing mechanism while we're in development. So from a very simple point of view, Hexagonal basically says there's an and the other architectures in a similar way say there's an inside and an outside. There's stuff that's inside, application and domain code, and there's stuff that's outside, which is the rest of the world. Somehow, it doesn't help if you got this stuff running in memory, but there's no way to see it, and there's no way to interact with it, and there's no way to tell it what to do. So we do have to interact with the rest of the world, unfortunately, because that's actually sometimes can be the hardest part of the application. If you write a simple calculator, the actual calculations are simple. It's all the UI stuff that can be really annoying and painful to deal with. And so because the way we diagram hexagonal-like architectures is this left to right asymmetry. So on the left side, we've got all our inputs to the system. Inputs, requests, whatever you want to call them. On the right side, we've got our outputs and our events that might be emitted, especially if you're doing event-driven like architectures. Some input may cause an application code to make a decision that then gets broadcast as an event to interested parties. So we've got some actor who is driving the application. And so the terminology that Alistair originally used for hexagonal has this idea of driving. These inputs drive the behavior. Stuff happens, and then the application code is now at the wheel, as it were, and we get things that are driven by the application. I've moved away from that because driving and driven are often confused, and the words are too similar to really differentiate what their purpose is. So I use inbound and outbound. So we've got inputs are inbound, requests coming in, and then we've got stuff that goes out. It does not mean that we don't get returns. It just means who's in charge, who's initiating that request, or who's starting that conversation. So the actor here starts the conversation with your application, and so therefore it's inbound. The application starts the conversation with your database, to store some stuff or maybe to query it, and then it gets a response back, but whoever initiated is in charge. So we can build up this architecture. We can say domain, no awareness of IO, It has no idea that any IO exists. It shouldn't have to care. But somebody does, and that's the application layer. However, it should have no idea about specific implementations of that IO, only abstractions. I want to retrieve an object. I don't know where I get it from. Maybe I get it from a database. Maybe I get it from a file. Maybe I get it from a remote system. Not my job. I'm just going to know that there's some way, some standardized way, i.e. an interface, that I can say, give me concert event 1, 2, 3, 4, and somehow it appears like magic. Now, in order to do that, you have to define that interface. How do I talk to persistence? You probably want something that makes sense, You want some find by, maybe you want some query mechanism. But again, the implementation is not of a concern of the application layer. Maybe I need to notify people that something happened, like I need to send you an email because you bought a concert ticket, so I need to send you an email with that confirmation. The application may not even know it's email. That may be required, but maybe not. That's a business decision. But somehow I got to notify somebody, and how I notify them, which email vendor I have to use. The code base that I'm going to show some examples from is a tool called Ensembler. And the email provider I was using started charging money, and I didn't want to pay money because I don't send out that many emails. So I have to switch the vendor. But luckily, I've got it as a hexagonal architecture, and I just need to plug in a different implementation of the emailer, which eventually I'll be doing not too far from now. So this boundary, the hexagon, is our application, what's called sometimes called our use case boundary. Yeah, so Christopher asked about separating the application layer into a part that interacts with the domain and the part that interacts with the persistence. So the part that interacts with the persistence or the notifiers, these things that are in this different color, these are ports. And so these are separate pieces, and the application talks to a port. So it knows about the port. It knows that persistence exists. It just doesn't know how it's done, which is great for testing, as we'll see. So our UI talks to the use case. And so you might split up your application layer. If you're dividing your classes into different pieces, you might have them divided up per use case. So there's the purchase ticket use case. There is the transfer ticket use case. And each one of those is going to be a little piece in the application layer that may or may not have to talk to persistent, that may or may not have to talk to a notifier, but it's going to talk to something at some point. Most likely, they're all going to talk to persistence to retrieve stuff, but they may or may not deal with the various ports that you have available. And you may know ports by another name, service provider interface. It's the same thing. You've got some service provider implementation that has to abide by an interface. So our whatever UI it is, most likely a web app or a mobile app, maybe it's a desktop app, who knows? Those still exist. Talks to the user interface. If you need something else to trigger behavior in your system, it might come through a message bus, because maybe there's some other system that needs to do that. Maybe we're on the listening end of some events, right? So there might be some message broker or message queue that does that. The application layer, you'll notice, doesn't know the difference and should not care. It is the job of these boxes here, these adapters, to interpret and translate the outside world into requests against the use case. Which means when we want to test our application layer, we replace those concrete things that deal with the messy outside world with our unit tests. Right? So testing against the domain, trivial. We instantiate the object, call some methods. Testing against the application layer, a little bit more work, but we don't have to worry about, is this JSON or a web, URL encoded web form? What the heck is it? We don't care. That's not our job. That's the job of the adapter. And you will test that separately, but you will only test it, decode things and encode things properly. And so you'll have some persistence implementation. Now, often people get all wrapped up in, oh, you're doing this because you want to swap out databases, but nobody ever swaps out databases. Now, generally that's true, although I have swapped out persistence mechanisms, but that's not why we have this layer here. We have this for testing. And so we're always swapping, because at some point we're going to need to write some tests, and maybe we don't even have a defined database schema yet. Maybe things are in such flux that we don't even know what that's going to be like, but I need to make progress on my application behavior. And so we'll see an implementation of that when we get to testables. And so then there's some concrete notifier. Is it sending text messages? Who knows? So dependencies flow inward, right? So to preserve the domain's ignorance of the outside world, it's nice to be ignorant, makes life easy, at least for the domain. And this is our system boundary. So our system boundary includes the application layer and the domain layer, and then the adapters that interact and translate between the outside world, and that's our system boundary. And one of the things that this does is encapsulates our domain. It provides a way to say domain objects do not exist outside this barrier, right? It's our boundary to say, here is inside, we've got concert objects and customer objects and ticket objects. Outside, we may have textual representations of those, and they may even be partial representations, but they are not the objects. We're not sending objects over the wire. We're not making that mistake again, except apparently our React server components did, and we won't get into that. I have to laugh because, like, we got rid of RMI and you made the same mistake. What are you doing? So let's look at a sequence diagram for how does this all fit together? So there's a lot here, but I'll walk you through it. So we've got our, what might be our API client here on the left, right? So that's initiating something, and it says, hey, I would like balance for account 23. I just got my tax refund, and so I'd like to see, is it in there? I literally just got a tax refund. It was great. I'm using Spring, so it's talking to Spring. Notice that it's a boundary object. It's kind of funny that we can now use those, and if you understand the diagram, it's like, oh yeah, boundary object, that makes sense. Its job is merely to say, how do I translate this path into a request for the inner part of the system? So I need to translate that into a call, right? So Spring is doing this for us. It translates this, you've got annotations and whatever, and it translates that into a method call, account info, passes you the string 23, because it doesn't know what the heck 23 is, it's just a string. The account controller, then this is your adapter. This is the part you write, and you say, somebody requested account info, and they passed me this parameter. I'm going to go and create a value object because I'm a good domain-driven design developer, and I'm going to use a value object. So I'm going to go into my core domain and say, give me a value object that represents 23. What this does behind the scenes is it's going to validate, right? So we say parse, don't validate. So if we actually get an account ID object back, we know it's a valid, at least potential account ID. It may not exist, but at least we know that it's formatted right and that it makes sense. Versus, ABC, it's like, what the heck is ABC? We don't deal with ABC. So we get our account ID, and then the controller says, hey, application, could you please find the account for me that has this account ID? So the application layer says, sure, I'm going to go talk to a representation and interface for the account repository. I don't know what it does behind the scenes. It's magic. Somehow, magically, it appears, and somehow magically it's able to instantiate an account object. So it instantiates the account object, and then that object gets returned. So now the application can say, great, I found it. Here you go. Here's the domain object representing account. The account controller says, well, I can't return this because it's an account object. And there might be even stuff that I don't want to reveal. So I'm going to transform it, right? So one of the jobs of these adapters is interpret the input and transform the output. I'm going to say, hey, give me a transfer object. Give me a view of this thing. And so the view is going to say, okay, what do I need to populate the view? I need the ID. Okay, I'm going to go grab the ID. I need the balance because that's what they're getting, and nothing else. So this view is customized for this specific API. If somebody was an admin and they had access to more information, they might call a different API, or perhaps authorization would be merged in here, and we'd get a different view object. We get our balance, and what we get back is an account view, and the account view is something that Spring happens to know how to interpret because it's basically getters and setters, and it just calls getters and returns that, right? So it goes and gets the properties and sees there's a get ID, so you must have an ID. Sees there's a get balance, so it must have a balance, and we get this JSON at the end. And so we can see that the adapter here on the left, the inbound adapter, translates the request into use case requests, right? Find account for. And then it translates the response, if it was found, translates that to just what's needed specifically for this API. So it's really important that we follow the dependency rule, right? Dependencies point inwards. Because if we fail to do that, then that's going to make testing harder. So let me start showing some code here from Ensembler. So the job of Ensembler is when I run ensembles. I need to know who's participating. I need to schedule them. People, like, I used to do this manually. It's not fun to do manually, so I created, like we do, create an application to do that for me. And this is a view. This happens to be the admin view. So I have a different view than those who actually are just users of it. And so I'm managing these events. They have rules around when you can sign up, how many people it can hold, things like that. So there's a web UI. There's this, well, this diagram will change because it's I need to change it away from SendGrid. And there's persistence. And then there is other external systems that it needs to communicate with. So it will automatically go and schedule a Zoom meeting using the Zoom API. So these are concrete outbound adapters, right? So The domain exists to manage the rules. It's the application that layer that says, hey, schedule ensemble means I need to go create an ensemble object. But in order to create it, I need the Zoom information, the scheduling information. So I'm going to call out to some scheduler. I don't know who. I could use Google Meet, God forbid. Some people like it. I hate it, but whatever. Could use other tools. Application doesn't care. My domain certainly doesn't care. As long as somehow somebody, I mean, it could even be a manual process, right? There's nothing to say that it sends an email to my assistant, please go schedule this meeting, and replies with stuff. And the adapter is responsible for interpreting that email, which you can now do relatively easy with LLMs. But the application layer doesn't care. And the domain layer doesn't care. All right, so there are different kinds of tests then, right? So getting back to IO free versus IO dependent. IO free tests, as I said, we just drive the domain logic directly. So what does that look like? Here we go, right? When I create an ensemble, it better not be completed. If I ask it, are you completed? You should respond false. Literally 2 lines of code, depending on how you count it. Well, when somebody clicks a button and says this ensemble has been completed, it should be completed, right? So I create it, I say complete, which is the command that I execute, and it basically should be completed, right? So these are all domain tests. And the thing about domain tests is they're really generally very easy to write because you're focused completely just on the behavior of the domain. If I cancel it, it should be canceled. And I have other tests. If you cancel it, you can't complete it, right? And these are all very easy to manipulate. So I create one, I cancel it, and I say if I try to complete it, it should blow up with an error, or maybe to return a different result. So those are easy. I want most of my tests to be like this because that makes them really easy to write. And so if we have no other concerns, right? If we don't have any IO concerns, this is really easy. This should be the majority of the tests we write. It may not be the majority of the time we spend on writing tests because these are easy, so you can write a lot of them. And then I find that you actually do spend quite a bit of time in the IO related and IO based tests. But for these, it's really easy. And you can show this to someone who knows the domain and say, is this right? And they may not understand what are all these parentheses doing here? What the heck does throw exception mean? It's like, no, just look inside. It's like, it uses words that they understand. Complete is completed is true. And so I find that stakeholders can relatively, with not too much additional guidance, read these and say, yes, that's what we meant. All other tests, though, are going to require test doubles. Sometimes this is known under the name mocks. I get pedantic about this because I find the term mocks to be a little confusing, because what do you mean by a mock? Do you mean an actual mock, or do you mean some other thing? So let's talk about test doubles, and I encourage you to use this terminology. It's been around for a while. Was described in I laugh because it's described in a great amount of detail in a book called XUnit Test Patterns by Gerard Mazaros. It's a 900-page book. So when I say it's extensively documented and described, I'm not kidding. And so test doubles, there are different kinds of them, right? Why do we need them? Because not all code is just testing against domain code, unfortunately, right? So we've got dependencies that we don't necessarily have control over in the real world. And so there are direct inputs, right? When I call a method saying, create this thing, here's the name of the thing, and here's what time it starts, those are direct inputs. Those are very easy to test with. Indirect inputs, like, hey, when it goes and schedules this thing, it goes and fetches and creates a Zoom meeting. That's hard to test. That's an indirect input. How do I test that? And make it predictable and make it not go over the wire. Right? So direct pass directly in as arguments. Indirectly is somebody else has to supply that. And so how do I test that? How do I predictably supply that information? Right? So here I've got the schedule service, right? So I've got test code against some scheduler. How do I do that, right? I have an indirect input provider. So the video conference scheduler, I need to be able to substitute the real thing for something that I can not only predict, but also program and compute and specify in my test. if I say when I schedule this, it should be scheduled and it should have this input from this external provider, I need to provide that at the top of my test. In addition, right, like we said, there are different reasons why IO will make your tests unpredictable. If you've got a card game like blackjack and you have a shuffle deck of cards, well, that's randomness, and that's unpredictable. And so if I want to try to test my card game, but it uses a shuffle deck of cards, your life is going to be pretty difficult. Similarly, it doesn't even have to be something like random. It could be, I want to test code that gives me the correct shipping weight, but there's other stuff that's hidden in other configuration. Maybe it's hidden in literally in configuration. This box weighs this much, this packing material weighs this much, or there's some external service that calculates that. But I just want to test, like, is this package this weight? And so there's information that's being used in my domain that I am not directly supplying. And so we need to provide a predictable indirect supplier. So I need to be able to say, I want to test if you deal the cards, this is the result. This player has blackjack, this player loses, and the dealer has this value in their hand. In order to do that, I need to provide something that provides a predictable series of cards so that I can write my test. And not only is it predictable, but you can see, why did that happen? Oh, you set up the deck so that these are the cards, therefore these are the way it gets dealt, and therefore these are the results. So if you can't control your real collaborators, they're external, or they're IO that might be unreliable or unpredictable, you need what's called a stand-in. And that's where the test double got its name, is like a movie stand-in, you have a test double. And instead of a stunt double, you got a test double that you can then program and configure in your test to say, when somebody asks you this question, you respond in this way. So I put the test double in sort of two categories. There's ones that's involved in this indirect supply of state, right? So we're involved in some state kind of thing. Dummies are sort of a special case. They basically supply no state. They just need to be there. Some code needs it. It doesn't matter for this test, but it needs it. I have to pass it in as a parameter or as part of its constructor. It needs to be there, and I don't have the real thing. I don't care. Stub is probably 90% of my test code in terms of test double support code. And this is the thing that you ask it a question, it gives you an answer. Sometimes it's always the same answer. Sometimes you can control what answer it responds with from your test. And then there's a fake, which acts like the real thing, but is in some way simpler or faster. Probably 90% of my fakes are stand-ins for database repositories. But then there's things where it's like, there's no state involved. Yeah, I'm getting to spies. There's no state involved. I just want to know, did you tell somebody something? Did you send out an SMS message? I don't expect any response except if it fails, but if it succeeds, I don't get a response. I want to know, did you call that method at the right time? When the purchase completed successfully, did you send an email? So if we want to verify behavior, who called what when, that's when we get into the test doubles that are considered behavioral ones. And those are spies and mocks. So dummies are placeholders, right? And so the state that they hold are neither read from or written to. They're just there. You need them, but they don't get used by the test. In fact, you can make sure they don't get used by implementing them as what are called crash test dummies, which if somebody calls and asks it for information, it blows up. Like, what the heck are you asking me information for? I said I'm a dummy, and you ask me for information, I'm going to blow up because you shouldn't have done that. And could be a naming convention, dummy suit, dummy member repository. And so here I've got part of the application where I need a member repository, but it's not used by this test. Here I'm making sure that when I create a UI view of an ensemble, that the ID is correct. Because what I'm testing is not this code really, I'm testing some other code. but I need this member repository. And the dummy is just an implementation that is dumb. Whoops. Is right. Returns null, returns empty, returns empty, returns empty. Right? It does nothing, but it's there. Stub, again, this is the most common one. Hard-coded return values, and its state is only meant for being read from. You call a method, it's going to return a value. That's what gets returned. Probably most often they're programmable, like you're basically going to change what they return in your test, because this test, I need you to return these cards. In this test, I need you to act like you're an empty deck. In this test, I need you to act with these cards. Or in this case, I need you to supply these dates. In this case, I need you to supply these other dates, because the test requires things in the future, in the past, and things like that. And you want to be able to control what it's going to return from your test. So you have stub deck or card provider or date supplier, different terms for these, for what you want to call them. So let's look at using a programmable stub. So here, I want to test that when an ensemble is scheduled, the link is fetched and it has the details for this conference. So here, I have a stub conference scheduler, and I program it with, when you get called, I want you to return these details. Now, if you've used mocking tools like Mockito or similar, this should be pretty familiar to you. That's what most people are using those tools for. The problem is it makes it very difficult to know exactly what's going on and what you're testing. And that's why I generally don't use those tools. There are other issues, but that's the main reason why, is it makes it far too easy to set up very complex, this thing returns this other thing, which is also a mock that I programmed to return this thing because it returns this other thing. And now I'm like, I don't know what you're testing. And it's not hard to write your own stubs. They're really not that hard. So here, this stub conference scheduler implements the video conference scheduler, which is the port that the application talks to when it needs to create a meeting or delete a meeting. But in this case, we're only testing create a meeting. So you'll notice that delete meeting, if somehow that got called in this test, that would throw an unsupported operation exception. Like, what are you doing? You're scheduling this thing. You're not deleting it. You're not canceling it. So we program it and we say, when somebody calls create meeting, return what you programmed it with. And so here I'm testing that the ensemble service, the use case that says schedule this ensemble with a video conference, I expect it to return the information that I specified up here. Right? So I expect the expected conference details to exactly match what got stuffed in. Right? So the indirect provider of information, this conference scheduler, I'm now testing that my service actually called it when it was supposed to, and it got back the right information. Now, it still means I'm going to have a concrete test for, did I call the Zoom API correctly? But I'm not going to run that very often. In fact, I actually have it set to manual, because unless they change their API or something, it's going to work the way it works. But I might have ways of faking it so that it throws certain exceptions like unauthorized and things like that, so I can make sure my application handles that correctly. And so fake is, unlike the other ones, handling reads and writes, right? Since it's mostly, not always, but most of the time when I create a fake, it's likely some kind of in-memory repository. And those are generally pretty simple to write. And so you can create one. In this case, it's a concurrent hash map. I map IDs to the objects. So you want to save. If no ID is assigned, because this is the behavior of a repository, we'll assign an ID for you. Sometimes you have client supplied IDs. In this case, it's a repository supplied ID. So it supplies the ID, and then puts it in the map. And when you ask for it by ID, it gets it out of the map. So really simple, really fast, and that's why I want it, because it's fast and it's in memory. Eventually, I will use test containers, and remind me, I'll show the code for that. But test containers are relatively slow. Overall, they're fast, about maybe 5 to 8 seconds. But compared to less than 30 milliseconds, that's relatively slow. So those are fakes, and sometimes you need spies. So spies are basically like they're listening, but they're not interfering. They're just recording what happened. And this is a case where I have a test. I want it to tell me if something happened, if the ensemble service called the right method to send out a notification. And so what that looks like in code is, in this case, it's a mock, and so I've basically a mock is a spy plus a way to assert that something happened. So mock is like the self-verifying spy. I record the information, then I can ask it, did I get the expected interaction? So basically, a mock is like a spy. Like a spy can just ask, hey, did somebody call you with this information? A mock is a self-verifying spy, right? So basically, drive the scenario and then ask the mock, did I expect what happened? Yes. I think I got these slides reversed. And so here I just want to make sure that what I got back in this case was, if I say cancel, that means I expect the behavior of the system is to go and delete that pre-scheduled meeting. And so I can basically make sure I got back the deleted part. And so it's all in the implementation details, but all these tests, these are IO dependent, but not based on real IO. And that means we can write predictable tests and they run really fast. And so I want to really nail this. When do you need test doubles? If you are testing domain code, never. If you are testing domain code, you should never, ever, ever, never, 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 never. Serious, never. I've made this mistake. Don't do it. You should not require test doubles. Why? Because they're in memory. You need one, you instantiate it. It takes no time at all. It takes you longer for Mockito to configure a mock than it takes me to instantiate an object that is a domain object. So if you're testing domain code, whether they're aggregates that have entities and value objects or just some entities that are around, you should never require test doubles. If you do, you've done something wrong. And I've made this mistake. Before I set this rule for myself, I had domain objects that were interacting in a way with random number generation. And I plugged in test doubles, but it's like, this feels wrong. So the rule is if you're testing domain code, you should never need test doubles. But as I said, not all our code is domain code. We need all that other code. And again, sometimes that other code outweighs the number of lines of code of our domain code. And so if you're testing where infrastructure is involved, right, anything that does IO, then you need it. But also test the real things. But you don't need as many. Right? You want to test that something that it reacts correctly when the API is down. Create a programmable stub that throws the exception or returns the result that you would expect if that really happened. Then because it can be hard to simulate some of those error conditions, and I think that's why some of our systems can be fragile, is because we don't do a good job. And look, I don't do a great job either of testing all the failure scenarios. Because how do you simulate that your Cosmos DB in Azure is failing in this specific way? Call up Microsoft and say, can you please bring your region down? No, of course not. But when it does go down, you'd like to make sure, because that seems to be happening, you'd like to make sure your system handles that. But you still need to test with real things. And so testing domain code should never require test doubles, even with an interface, because the interface should be about domain stuff, and you should have concrete implementations of those that are domain and in memory. So Husam asks, what if you use part of a domain that needs a domain service to interact with another bounded context? Likely that is going to cross some boundary. So I've been talking about sort of boundaries within a part of a system, right? The application is sort of that part of that boundary. If you write a modular system, your bounded contexts are going to be in different modules. They're going to be, right? This is where we get modular monolith from, the good kind. And so it's going to have to cross a boundary. And that boundary, you're going to want to decouple. And so that I would treat as, even though technically it's in memory, I would treat that as, it's kind of IO. It's out of my process. It's out of my module. Because what's actually great about that is if you then say, hey, we need to pull this module out because we need to scale this part up a lot. But we don't want to have to scale up the entire, right? We don't want to have 100 implementations of the entire monolith. We need this one module that's doing a lot of work, and we need to scale it 100 times. So let's pull it out into its own service. Well, now you've got those boundaries built in, and you don't have to change your code, at least in your domain and application layer. You're going to have to change the integration code, the code that talks to that. Instead of talking across that module boundary within the same application, it now goes across some network likely thing. But that's a lot easier. So all of these extra things, right? These ports and so on, there's a cost to them. It's a lot easier to just write all your code and mix the stuff. At least it seems easier. And to increase testability, we often have to create more things than we might otherwise think we need. And we might lose a bit of simplicity. And it's a trade-off, which means I could decide not to do that. I could use my judgment saying, I don't want to do that here. I'm going to do this thing in this specific way, knowing that I'm breaking the rule, but because maybe I'm not sure what the boundary is or other things, but I know that there's a big cost to that from a testability standpoint. So in my ensembler system, I have an invite thing where I onboard new people. That stuff just talks to the database directly. The controller talks right to the database. And I made that conscious decision because it's rarely used. The only user of it is me personally. And so if it fails, it's on me. I can go and inspect the database directly and insert rows directly in it. So it's fine, right? And so we make these trade-off decisions with full knowledge of what the cost is. And so you want to use one of these testable architectures. I love Hexagonal. I don't care what you use. Just if you want your code to be easier to test, keep them separated. Keep your IO separated from your domain logic. So there was a question about the test container, so I'll show that. But if you've got other questions, queue them up or ask them in chat. And so here's Ensembler. Actually, let me go to jitter ticket. So Spring has a way of interacting with test containers that makes it really easy to, if this is the first time the test container has ever been run, it will possibly pull that image down from wherever it's getting it from and start it up. So the first test might run really slowly, but then every subsequent test is going to run really quickly. And the way it does it, and this code is open source, and I'll provide the links to it. And so you use a combination of data JDBC test with service connection. And the key is this part that says with reuse, and then we manually start it. But if it's already started, because we said with reuse, it won't restart it. And so once it's up and running, every time now you run tests that use the test container, the Postgres is sitting there up and running available for interactions. If I restart my machine or I need to use a different version of Postgres, right? I'm going to maybe 18, then it will download the image, but it'll only be the first time. Every subsequent test will use it, and it's generally pretty darn fast. So let's see, when you create a double for the other bounded context, you're running the risk of missing changes or having poor assumptions of that bounded context. How do you make sure your tests aren't blind to the changes? I mean, when you're talking to something in an external service, whether it's another part, right, it's another module, or whether it's another system, you're defining the interface, the API for talking to that. So you have to do that. You have to say, what is the API for talking to this module, this bounded context? What is it doing? What is its API? And so you need to define that. The nice thing is if it's all in the same repository and you make a mistake, well, you're the only one affected, and so you can go refactor that. The minute you pull it out and deploy it separately, now you've got to raise the level of formality. And actually the balancing coupling books talks about this. You need to go from model coupling to contract coupling. You can get away with model coupling, sharing the information directly, but then if you pull it out to a separate service, now you got to go contract. And what that really means is you're raising the formality of changes. And so you want to, if you can, delay that until it's kind of been in use, because then it's like, now I've got it right. Right. So when you're unsure, make it easy to change. And when you've got it more established, then you can start pulling things out and define the contract. But if you try to define the contract up front, that can be really difficult because, like, I don't know if I got it right. And if you get it wrong, well, you get it wrong, and then you have to change the contract. And hopefully that's easy, but it's not always easy. So Tony asked about applications that are database heavy with lots of complicated queries. So the database query part is an adapter implementation, right? So if we look at Hexagonal, some people say, well, like, well, right, what if it is database heavy? What if there is a lot of stuff going on there? Hexagonal doesn't answer that question. So you got to figure that out. One of the things that I like about Hexagonal is it makes it very clear sort of who's responsible for what. I generally don't want logic in my databases. So my queries are going to be queries, and they might have joins, and they might be complex joins. But I have to decide, what does the application code need in order to execute this use case task? Now, if, as Laj suggests, if there's kind of no domain behavior at all, then again, you can make the decision, use your judgment to say, this separation of concerns doesn't help me, right? Because you have to think about, why did I separate these concerns? Because I've got a domain here that needs testing. And that's the primary value of the system, is that it's implementing this behavior. But if all the work is in the database, and so I talk about systems that are basically translation systems, stuff comes in from one place, I translate it to some other format, and then I send it out to somewhere else. There's no ifs there. There's no decision making. It's just transformation. Well, if you've got no decision making, you don't have a domain, really. And so don't do this, because there are translation layers here, and these are costly in order to encapsulate and separate the outside world from your domain. But sometimes that trade-off isn't worth it. And so A-frame is fine. I mean, then you've basically got, for me, like, I didn't start with Hexagonal and say, oh, Hexagonal, that looks great, let me adopt that. I sort of always think about it as, like, I backed into it because I said, how can I make this easier to test? How can I isolate this to make it easier to test? How can I make it easier to test and faster to test? And you keep nailing that down and iterating on that, and you end up with something like this for the types of applications that I work with. If there's not a lot of decision making or domain, you're going to end up in a different place. And so that's why I call it testable architecture. This is one way to do it. But if your needs are different, start with the tests. How am I going to test this? Ask that question. And if you can, write your tests first. So Gordon asked about programming language selection. In some ways, it makes it easier. So languages that don't require predefined interfaces, especially languages like JavaScript and so on, in some ways that can be easier because you have less work to do and you have less of a straitjacket. But it all totally applies because it's, again, about separation of IO versus not IO. Whether you use an actual port, an interface, a language interface or not, doesn't really matter. I happen to like Java because the strictness of the typing helps with refactoring, automated refactorings. But the language is sort of agnostic to that. So when I say domain, I'm sort of the domain is the objects that have the state and have the rules around that state, right? So can I cancel this ensemble? Well, it's already happened, so no, you can't. That's a rule based on state that's contained within that object. The use case is somebody wants to cancel it. And so the application layer is implementing that use case. And so when I'm test driving my code, I'm starting with, what is the use case? What do I need to do? I need to schedule this ensemble. I need to cancel this ensemble. Somebody needs to register for this ensemble. And often the use case is coordinating, possibly among multiple different entities that have to be retrieved. But then it retrieves those entities and then relies on those entities to do their own job. And so to separate, so I made this mistake early on of, or I wouldn't say mistake, I would say I didn't separate the domain and application layer, and I found that things were harder to test. I was constantly having to create test doubles for things. And so if you find yourself creating test doubles, you know you're not in domain. You know you're not in pure domain, because you shouldn't need test doubles if you're in pure domain. And so what you can do is, if you find yourself using test doubles, take a close look at what does this test double represent? Is it some external thing that I need to basically define an interface for, and therefore write a test double for it? Well, then it probably should be called by the application layer. And so again, sort of what application layer looks like is this very transaction script like thing. Right. So if we go to our ensemble service, right? So what does schedule ensemble do? Right. So this is the use case. This is something that somebody has written some stuff on a form and clicked a button, literally. So we create the ensemble and then we do a save and notify. If I want to change the ensemble, well, what do I need to do? I need to find it, change it, and then save. Right. And this is the common pattern that you'll see in these kinds of use case application implementations. Get the stuff, call methods on, right? And by stuff, I mean the domain objects, load the domain objects into memory, call methods on the domain objects, and if everything went fine, persist those domain objects. And whether you're doing CRUD sourcing persistence, as most folks do, or event sourcing, which is something I've been doing a lot of lately, it's the same pattern. Somehow you got to get those things into memory. How they get loaded into memory, I don't care. At least application layer doesn't care. I personally care, but the application layer doesn't care. Load it in, execute stuff, persist. And then there are the side effects of, hey, I just persisted this. I also want to notify somebody that this happened, right? So here we changed it. So I need to go tell Zoom that meeting you scheduled, I need you to actually delete it and reschedule it. And you're going to want to do testing at the use case layer. In fact, I generally start at that when I'm developing new functionality, because then that will tell me what do I need from the various entities and aggregates and value objects that I have. And so to recognize that you've got them mixed up is if you see domain objects referencing anything other than another domain object, pull that out. Right. So application layer is much more about coordination and orchestration. Right. Find the thing, do that, save it, talk to this external video conference schedule to create the meeting, and then change the meeting link, and then I save it again. Right. So here it's like I load it, I change the date, but I also need to go and change the Zoom meeting. So I go to the Zoom meeting, change that, and then persist that new meeting link. Right. So that's like stuff that needs to happen, but that's not really domain stuff, right? A stakeholder is like, well, yeah, of course that happens. Like, but, right? And so this is where it starts to get, right, not pure domain in this wonderful world of pure rules and state, which is a wonderful world to live in, except you can't live in it. And so anything that's coordinating with these external pieces, and coordinating across aggregates, and this is where the domain-driven design aspect comes in, that's done in the application layer. So service is usually, so here service is application layer, and I've got different names for this. I don't like service, and so for me personally, I have to walk a line between educational use. So generally people understand what service means if I have ensemble service, and purchase ticket use case. It's like, what the heck is that? Oh, it's a service. Oh, okay, I understand what that is. Right. And so naming is kind of a thing. And generally I like small use cases that are literally this use case, like schedule. And you can get to command objects and things like that. So the use cases are the things that are driving this process, right? Fetch this, go get this, look this up over here, get this information, and then push it into this, and then persist. So Christopher asks, separate the persist code from the notify code. Yeah. And there's a bunch of different things you might want to make sure that you don't notify somebody an email if for some reason the persistence failed, and there's patterns, outbox patterns, and stuff like that that you may or may not need, depending. And then that's just a different way to organize the code. But that's sort of implementation details, and also depends on the framework that you're using. So Gordon asks the heavy question of how do I get people to think more about testability? The way I do it is say, how much time are you spending puzzled over why stuff doesn't work? And don't ask them, have them measure it. We are terrible. As humans, we are terrible at estimating how much time we spend on anything, which is why asking people in surveys, how much time do you spend on X versus Y, is useless, because we don't have a good judge of that. Have people journal and measure how much time are you sitting in the debugger? How much time are you sitting just puzzled over why something doesn't work? Measure that over some time, and then say, let's examine one of these situations where, wow, this took you 2 days to troubleshoot this. Why? Well, I had to run it through the debugger, and every time I did, it took me half an hour to get to the point where I did, and then, oops, I stepped over it too far, and now I got to back up and start over again, and it took me another half hour. What if you had a test that could automate and get you to that position and show that, and in fact, observe it for you, right? And that's what I found. I spend almost no time in a debugger, almost no time. When I'm in a debugger, 95, 98% of the time, it's because I'm unclear about what the framework is doing. What? It said multiple X, and what does that mean? And so I'll debug through their code, not my code, because my code, I got tests. And so I find that collecting that kind of data, and it may take you a few weeks. And if you can automate that, so there are tools, that might be a bit intrusive, but could measure how much time you're spending doing certain things. The more objective, the better, as long as people agree to it. And use that data, and then do experiments. Say, let's try next time we encounter this. In fact, let's get together in a room and see if we can make that code more easily testable. Just that piece. And see how that goes. And then over time, invariably, you will find that it will start taking you less time when you're troubleshooting and debugging, because you have better testability.
Hey, Ted.
Yep.
I have a question for you.
Yep.
Would you mind if I invited people, if they've got more questions, to unmute themselves and we can have a little bit
Absolutely.
more conversational?
Yeah.
Yeah, we like that. It's just there was, some noise earlier.
Yeah.
Thanks. Yeah, so feel free to.
Yeah. So Diana asks, that's why I don't pronounce it. I call it testable architecture. Because it's not pronounceable. I've spent far too much time trying to come up with an acronym that's actually pronounceable, and just like, it's just testable architecture. And the fundamental thing is separation of IO concerns. And again, it's nothing new. Like, I didn't invent it. I backed my way into it, and now you don't have to do all that experimentation work. Just if you see IO, pull it out, make it separate. What else? I should make it a t-shirt. It goes all the way at the beginning. There it is. You can tell, like, I'm playing around trying to get something semi-pronounceable, and it's like, it's not working. Yeah, I mean, in general, I don't like I don't have I try not to have a lot of rules where it's like, this is the rule forever. That's one of them that's like, if it doesn't abide by the rule, like if you find yourself, you think you're testing domain code and somehow Testable feels like it's needed, you may do it, but it's most likely the code telling you, and now you know what to listen for, that maybe there's some IO here. Like, why do I feel the need to substitute this thing? Sometimes it's just habit. Like, oh, I have an interface, let me substitute some Testable for it. It's like, yes, maybe, but probably not.
Can we get the oh, hold on. Is that the linking question down there, the bottom right corner? Or you had a few interesting links there, and I just want to put them back in our chat. Okay, great.
Yeah, pretty much if you just go to ted.dev, you're going to see about me. If you go to ted.dev/talks, that'll get you to all of the talk stuff. Past talks, slides, scheduled future talks, things like that.
Perfect. Thank you.
Yeah. Yeah, Christopher, is that really more pronounceable? If you come up with something better, please let me know. But I find that just testable architecture really, even if it was a good acronym, it's still not going to help. It's like, what does it stand for? It stands for this whole thing. It's like testable architecture is separation of IO from concerns. And just do that. And then, using test doubles and really understanding the role of the different ones, and when to use them and when not to use them, that is really important. If you find yourself using a test double and you're in the domain, it should be a little signal, right? The code tells us stuff. And sometimes it's telling us stuff we don't understand what it's saying. And so I think hopefully this will help you understand that. So trying to ask a question, this is a bigger general question, is like, what if there's stuff that's crap and that I want that is too big to fix? That happens. And so you have to be strategic. You have to say, is this in my way? So Tim Einiger, talks about, is this impeding my progress? Is this in my way? Is this in my path? Or is it sort of off to the side? I was driving by it and I saw it and it's like, oh my God, that's a trash dump. You don't stop at the trash dump and say, let me go clean this up, unless it was like in front of you and blocking the road that you're going down, in which case you might have to do a little bit of work to move the dumpsters aside. But if it's not in your way, leave it alone. Because if it's in your way, then you need to address it. But you'll never make anything perfect. You want to do just enough. And so this is where learning good refactoring skills is so important, right? Being really good at doing refactorings, a combination of automated ones, perhaps even AI assisted, learning how to do that. Because sometimes it's just like, okay, I don't have to clean the dumpsters. I just have to move them out of the way so I can squeeze by. And that applies to almost anything. Like, I've got cruft in my code. I've got crappy code. But I haven't had to touch it because I'm not adding features in that area and it works and it's reliable, so I won't touch it. So it has low volatility, right? It doesn't change very often. It's not in my way. It maybe is not even connected to the core part of my business. And so I'm not going to worry too much about it. But the stuff that's core to my business, and again, this is, I feel like I'm promoting Vlad Konono's book on balance and coupling, but he talks explicitly about these things, about how it helps you make those decisions. And it can provide some language for you to talk about your colleagues about, yes, this sucks, this is ugly, this is crappy, but it's not our core business, or it's not very volatile, so let's leave it alone. Or we've been avoiding this for a while, which has actually been preventing us from making these changes that actually the business wants, so we need to go to clean it up. Yeah, it's a good book. Yeah, happy to hear from you all on any of the social media or email. As I mentioned, I do live coding, so all this stuff was developed live. If you really wanted to watch the hundreds of hours that it took me to develop some of this stuff, you could, but it's more about just having fun watching other people code, because I find it's things like tutorials don't always give you, they skip over what I think is the most important part, which is, I don't know what the heck to do next. right? The whole thinking process. And I think that's really important. And so for better or for worse, I spent a lot of time scratching my head on my streams. Like, what do I do? How do I solve this problem? Anything else? Any final thoughts or questions? And if you think of anything after, of course, hit me up. Like most people, I have my own Discord, so you can ask me there, or you can just hit me up directly through a direct message or email, whatever works for you.
Yeah. Ted, thank you. This is lots full of things to consider and try and implement a little bit at a time.
A little bit of that's slow and steady.
Yeah.
Yep.
Yeah.
Awesome.
So asking questions right now, like there's too much in my head that isn't clear.
Yep. I think this will make a good video to revisit.
And it'll hit you when you actually try to say, hey, I saw this thing and I tried to do it, and it's like, wait, there's this little piece I must have missed, or maybe wasn't explained because I can't explain everything. Please don't hesitate to get in touch. I am, yes, I can talk about this stuff and I teach this stuff, but I love hearing questions because that first of all, I love helping people. That's why I do this. But also like it then informs, oh, I should make sure to mention that next time. Like some of the things from this presentation were built on questions that previous people had. So do not hesitate to contact.
I'd like to add, Ted, your more specific examples on refactoring and whatnot are quite amazing, and I use them almost daily.
Awesome.
So for other folks interested in more deep dive, I would definitely check out more of Ted's stuff because there's some phenomenal nuggets in there.
Thank you.
And Zombie being one of my favorite acronyms.
Yes. Yeah, I didn't make that up, but it's a great one. Once you learn what it means and how to use it, James Grenning came up with it. But like, it's lots of good techniques, and like I know AI and LLMs are all the rage and generative stuff, and I know a lot of other folks are doing a lot of stuff with that. But you still have to know how to refactor, and that's why most of what I focus on is refactoring. Yes, you need to know what goes where, like what is your destination. But learning how to get there in a safe way, I think, is so important, especially when somebody plops 3,000 lines of LLM generated stuff on you. Not that that's ever happened.
And Adam, where did you? So, what was your favorite way to like pick up these tips from Ted? Anyway, how did you?
I actually got really lucky. Lada is one of my mentors, and she actually pointed me towards Ted in one of his classes. So I was lucky enough to work with Ted directly, learning a lot of things about not only hexagonal architecture, but a lot of these concepts, and even furthermore on how to refactor code, specifically in Java, with some of the projects he's got. So one of my favorites, and one of the ones we did was a blackjack project, actually.
Yes. Yep.
Very fun and very interesting, and we did ensembles and such. And yeah.
Thanks a lot.
Absolutely.
Anna, go ahead.
I am curious, Ted, if you are on the Calgary Discord. And what I want to say is that people who put up a nice slide like you've got up right now are letting us know how you prefer to be contacted. But if Discord is one of the ways that it's okay to contact you for the first thing or for a discussion in a group chat, then it would be another incentive for people to join Calgary Discord. But it's your choice, Ted. So if you prefer we send you an email, then stick with that.
So since one of the nice things about Discord, unlike Slack, is since I'm on Discord in far too many Discords, I'll join the Calgary room. But if you send me a direct message on Discord, that's actually that's actually how this got scheduled. Is it was a direct a DM on Discord, and so that's probably even preferred over email because it allows for a bit more back and forth.
Yeah, you were so responsive. I'm so grateful. Thanks a lot. Like getting to meet you was, you know, the whole thing's been a pleasure. So thank you.
Thank you.
Great. Thanks, Ted. We invite you to
Yep.
join Calgary Discord, and
Yep.
that'll be another way.
Absolutely.
Well, I think we might be wrapping up. Hey,
Yeah. Brains are probably full. That's good. Let it settle, let it sink in. Get a good night's sleep, let all that stuff get reorganized in your brain while you sleep. That's what happens. Consolidation of memories. And you'll wake up with like, what the heck was that? And then you can contact me and I'll help you along.
thanks. Well, thanks. Thanks again, Ted. Thanks very much. Actually, you know, on that note, I'm gonna put the Calgary Software Crafters Discord link in our chat again. And the donation link for anyone who's still here. But yeah, I wanted to say thank you again for you know, giving us your time and your experience, your knowledge, and thanks
Pleasure.
to all of you who attended. Thanks so much.
Yep. Thanks for the great questions. That makes it worth it.